Hello my friends, welcome back to the Innovation Lab. In this video we are going to do another product review, and this time we're going to be looking at this microcontroller board. It's called the Atmega Pro Micro 32U4. So this is a compatible version of the Arduino Micro, actually pin for pin. So there's a lot of things you can do with this board, but you have to start from knowing where to buy the board or where to get the board from, and again how to configure it, how to program it, and to do multiple applications. So for those of you who have seen my video, my subscribers have seen my video that I made about a spot welder build. So this here was what I used to program the weld pulses for that spot welder. So if you want, you can go check out the video. I'll link the video to this one so you can go check it out. And this video is going to be basically for beginners. I know some of us out there are like very advanced in programming and coding and microcontroller configurations and things like that. So if you're one of those people, then this video will not be for you. But if you're a pure beginner and you want to know how to get started on microcontroller programming and using products like this, Arduino programming, then I would say you're at the right place. And I'm going to break this video into multiple tutorials. So I plan to do a couple series between now and the next couple weeks to go over how to configure, how to start coding, doing basic functions. So yes, so let's get to it and do an overview on this and show where you can get them. So if you're building something that requires you to have kind of a microcontroller design to allow you to program different functions, so you have one of the options out there is Arduino Uno. And if for some reason the Arduino Uno seems to be a little bit too big for the project that you're working for, or the space that you have in your enclosure or your circuit board, so this is where this guy comes in. So this is like a knockoff version of the Arduino Micro. So it's very compatible with Arduino Micro pin for pin. So you can try using something like this. So you can see how small this guy is. Actually, if we go ahead and measured it, so you can see on this actually measures about less than 1.5 inches in length, and in width here you can see measures actually less than one inch as well. So it's very small, and it can fit to any circuit board very easily. So you can easily mount it to any board that you're working with using these standoff pins that it comes with here. So that way, and you can program it through this USB port here. Yeah. So if you make the comparison, this is the typical Arduino Uno, and this is the Arduino Micro. It's very small. You can see it's very small, and comes in very handy, and you can accomplish most of the functions that you can do with this, also with this guy. So if you wanted to find some information about the Pro Micro board, so you go online, you go on Google, type in Pro Micro. So let's go for the Pinout. So you find a lot of vendors that will come up for this product. They may have different names because of the vendors, but it's usually the same microcontroller. They all use the same microcontroller, which is the Atmega 32U4, and it runs at 5 volts input, 60 megahertz clock speed. I misspoke earlier about this board being compatible, pin for pin compatible with the Arduino Micro. that is not necessarily true, but they end up using the same microcontroller, and also this board is compatible with the Arduino IDE development environment. So this board comes with a USB connector for programming it, and it has 9 10-bit ADC pins, input pins, and it has 12 digital I/O pins, 5 of which are PWM pulse width modulation capable. Then we have 2 pins that are for receive and transmit for serial communication. And so this board, as you saw in my measurements, this board is like very small, 1.3 inches by 0.7 inches in width. So if you're buying it through this vendor, maybe I don't know why it costs $19.50, but if you want to get it cheaper and possibly quicker, you can check it out on Amazon. So here is the board on Amazon, the same specs as you can see, maybe possibly not the same vendor or manufacturer, but and I believe this is the one I'm using. The same exact specs. So this picture right here is actually better to look at the pinout. So this board comes with 24 pins. So if you start from the left over here, you see the pin 1 and 2 is your transmit and receive for serial communication. Then you have the 2 grounds. Then from pins 2, well, they're not exactly pin 2, but the pins that are labeled 2 to 15, as you can see here, are your digital I/O pins, and your PWM pins are mixed in there as well. And I'm going to show you another page that shows that. So the pins are labeled A0 to A3 are your 4 ADC input pins, and you have the VCC pin, the reset pin, the ground, and the raw. I honestly don't know what the raw pin does. I have not tried it out. If you do know what it does, leave me a comment in the below, so I can also learn from you. And so if we look at this website here, it's called codery.com. So they kind of provided like a more detailed label of what each pin does. As I mentioned, it kind of goes over almost everything I've talked about. So if you're looking for the PWM pins, I believe there are pin 3, pin 5, pin 9, pin 10, and pin 14. All the other pins are, all these pins have multiple functions, so it depends on how you configure them, which I'm going to show, the pin mode that you can configure them to, and they will perform accordingly. Yeah, that's it for this. So if you want it cheaper, you can find it on Amazon. And so you can get a pack of 3 of these with the standoff pins for $24 each, which breaks down to about $8 or so per board. Or you can, for some reason, if you want to buy more expensive, I don't know why you would want to do that, but yeah. So so that's the breakdown of the board. So now let's go into the actual schematic that you have seen on my breadboard, and then we test a sample codes and see the actual function of those codes. So this here shows the overview of my breadboard, how the board is being configured, so you can program a code and test the code and see what the LEDs are doing. And so I'm going to do a quick animation here to kind of run through how this board, kind of the concept here. So the first thing you see is the power supply. This could be a battery or any 12-volt source, or maybe something higher. Then from there it goes into this 7805, which is the 5-volt regulator, and I bias that with 50 ohms. So from the 5-volt regulator, I added MOSFET, an N-channel MOSFET, to serve as a current boost, and is configured to be a source follower, and I also bias that but with 10 ohms. So next you see the actual Arduino board. This is a 24-pin board with a USB connector for port for programming the actual board. Then first thing you need to do is to tie it to ground. This tie in the ground pins there, as you can see. Then from there we're gonna have VCC. So this will be the regulated 5-volt output coming from the linear regulator. Then I added a push button switch to serve as my input, basically to when I press it, the microcontroller will perform and execute an action. Then lastly, I added the 5 LEDs to test my code, to make sure that the code is doing what I want it to do. And to bias those, I use 500 ohms to bias those, and here and pull them to ground. So one of the things I found to be very helpful is when you are configuring an input, you have to make sure that you pull that input pin down by for this board I used a 15K. If not, you're going to have issues. I kind of found this the hard way. I built the board, programmed it, and nothing was happening. I had to break the code and I did all kinds of things and it wouldn't work. So don't do that. So let's run through the animations to make sure that the code performs as intended. So the first line of code basically turns on all the 5 LEDs and turns them off, and it blinks on and off and on and off a few times. Then the second portion of the code alternates between the first 2 LEDs and the second 2 LEDs, and there is some delay in the loop there to make sure that you can actually see what is happening or what to expect. There you have it, my friends. So that's the schematic in a nutshell, and I added some animation. And so yes, so if you're about to build this, if you did have a need to build this, follow this schematic exactly as it is. So each of these represent the board, the pins on the board, as you look at the board from going from left to right. So you see that these are numbered, and so yes, so and you can, follow the pins on the board, follow my lines of code the way I had it. You can now modify it to whatever you want to use it for, and you can replace this LEDs here with MOSFETs, so to drive a different kind of load. So yeah, let's get to the actual build and see what it looks like. So the first thing you need to do after you have configured and built your development board on a breadboard or any circuit where you're going to have it or test it. So now what I like to do is to create a folder. In this case, I have this folder called Arduino. So I made a subfolder for this video called Innovation Lab, and under Innovation Lab I had, because I wanted to break this tutorial into 2 parts or 2 videos. So the first video, which is what we're doing here now, will be the tutorial. I call it tutorial 1, fun stuff. So if you go in there, I broke it again to the different functions that were LED patterns, the display patterns that we are going to be testing. So the first one I call the blink. So if you go on the Blink, then you open the Arduino development environment, which is a software tool. So the very first thing, I had already written this code, and I'll kind of go over it briefly. So the next thing you need to do is to come back to your board to make sure that your USB cable is plugged in to the USB port on the Arduino Micro. So let's go ahead and do that. So now that our USB cable is plugged in and it's receiving 5 volts from the computer. So now we come back to the software environment here. So what you can see here is you need to make sure that the board actually is talking to the software here. So, and to do that, you go to Tools, and you go to, for this board, it was recommended on Amazon by the manufacturer or the vendor that you use Arduino Leonardo, and I found that to be very useful information because it does work. Then secondly, you need to go back to your tools and make sure that you have the COM port properly configured. So for my computer, the Arduino board is plugged into COM port 6. So we configure that, and now we get into your test code. So for this test code, I call it the Blink. So the Blink is basically, I'm trying to have, I hooked up, if you look at the board here, I have so if you look at the board here, I have 5 LEDs configured as output that I'm gonna use to kind of sample different patterns of display. And over here I have a push button switch that I'm gonna use as an input device to tell kind of to instruct the micro board on what to do. So now we come back to the code. So this code is called Innovation Lab Blink, and so here what I have done, I'm not going to be able to go over all the code line by line. So I've configured, this first section is basically configuring the inputs that I'm going to use. The first 5 inputs here are configured pin 2, 5, 7, 9, and 16, and then I gave the names as LED. I guess I could say LED 0, LED 1, LED 2, 3, and 4. Then I had one of the pins configured as input, which is pin 15, and I called it in pin, so declaring it as an input. Then I added a bunch of variables here to serve as, to collect data from the input pin, and also use as as a counter variable on the code. So coming down here, it says void setup. So under void setup is where you go the next phase of the pin configuration. So you set the pin mode. The pin mode determines if you want to set it as an input or as an output. So as you can see here, the first 5 pins I have are configured as outputs, and that's gonna be where my LEDs are hooked up to. And the pin mode, the last pin, which is pin 15, is configured as an input. So again, I'm not gonna have time to go through all the code line by line. Well, basically what this does here is the first line goes to read the pin, the input pin, and what it is doing is it's looking to see if I have pressed the button, the push button switch. So it's looking and looking and looking to see if I have pressed it. So if I haven't pressed it, it's not going to do anything. It's not going to, the remaining portion of the code down here is not going to execute. So then here, this conditional statement here, if, says if I have pushed the button, which means the button is now high, then continue to do all of this fun stuff here, turn on all LEDs, turn them off, and do some fun stuff, so which we are going to see. So we have it plugged in, our code is good, but you don't know that your code is good, so you verify by going to this button here, So you click on this button and you will see it runs the code. You look at your board. That's also another way you verify. Let's do that again. So you look at your board, make sure you see those heartbeat LEDs blinking. So that's a way to verify that your board is properly connected. Then when you look down here on the software, on the IDE, so you see it says done uploading, and it gives you some message here to tell you how much memory you used and how much you have left. Then but then if you have an error, so when you do this, that means your code technically doesn't have any errors, but that doesn't mean that the execution, there is no error in the execution from what you had intended for it to do. So but now, for example, if you do have an error, so let's say for our count variable, if we spelled it wrong and we run the code, this would be a kind of an example of what an error would look like. So the environment will tell you count was not declared in this scope, so which means there is an error. And I found these errors most times to be kind of a typo. If your variable names, if you spell them wrong, you'll run into this kind of issue. So you correct it and you run it again, and there you have it. So the code compiled and uploaded. So here, if you verify, you'll compile the code for you, and if there's no issues, it says done compiling. So the next phase will be to actually upload it to the microcontroller. So when you do that, it's uploading, and when it's done, it says done uploading. Then it gives you all that message that I was talking about how much memory space you used and what you have left. So now that we have that code implemented, so now let's see what it actually will do. So for this code, so when we push this button here, so for this code, when we actually go ahead and we push this button here, see the LEDs will blink, all of them will blink. Then we have a set of two alternating as they blink, which is exactly what I wanted it to do. Yeah, so that's about it for the first code. Now for the second code, let's close this one out, and we go back in here, and the same thing, but here this one I call Sirens, which is kind of I had in mind to kind of display, if you look at a cop car, how the scrolling lights of that goes with the siren, or for a cop car or a fire truck or an ambulance. So kind of mimic that function. So again, I should have changed this name because it's no longer Blink, so it's now Sirens. But then that doesn't really matter as a comment. So the same thing applies. Configure the pins at inputs and outputs. Then wrote the code down here, which is kind of establishing a pattern, and write in this conditional statement. If the input is high, do this. If not, then watch this counter. Once it has done it like 5 times, then I want you to stop. Or so in this case, actually it's not going to stop, it's just going to keep going. So now let's first of all verify to make sure nothing went wrong. There shouldn't be any issues. Then we upload. Then after uploading, now let's actually test the board. It's that easy. So push the button. So as you can see, it's scrolling and scrolling and scrolling. So, but now, if you really want to see what's going on, so what we can do is to increase the delay time to 1 second. Now we have it to 100 milliseconds. Let's put it to 1 second. So which is 1000 milliseconds. So let's program again. So it's done uploading. So we'll run it again. Now you're going to see that it's going to be much slower. So you can actually see what's happening. So it's turning on the LEDs and is leaving them on, and then until it gets to the end, and it turns them off and it reverses the action, which is exactly what we want it to do. So, and if we want it, we can increase the speed a little bit to see what will happen. We increase it to, let's say, 200 milliseconds. The same process. So now push button switch. Now our push button switch. So it's capturing the same pattern, but a little bit faster, but not as fast as when the delay is reduced to 100 milliseconds. So that's it for this one. So the next one is going to be an actual Christmas light function I made a while ago, and I was able to use this to actually design a Christmas light for my house during last Christmas. And instead of using these LEDs, so what I did was I connected relays. I used the Arduino board to drive MOSFETs that drove relays. Then the relays drove the group of Christmas lights that I had. I put them around the house, and it was very, very nice to see. All right, my friends. That's it for this video. I hope you found this useful, entertaining, or you learned something from it. So don't forget to like, share this video, subscribe, and yeah, so see you in the next video.